Hello everyone, and welcome to this presentation on the SF-260 FHM electrical system. In this video, we'll explore the various electrical systems that power our aircraft, ensuring safe and efficient operations. Overview: the SF-260 FHM electrical system is comprehensive and includes several critical components. These are the main electrical power system, the light system, essential for visibility, the flight control system, which includes electrically operated components like flaps, the landing gear system, for safe takeoffs, and landings, the attitude and direction system, helping us maintain situational awareness, the engine fuel indicating system to monitor our fuel levels, and finally, the engine ignition and starting system to get us airborne. Let's dive into each of these systems in more detail. Electrical power system 24000. Electrical power, controls and indicators. The electrical power system is the backbone of the aircraft, providing the necessary energy to all other systems. We'll start by looking at its key components, starting with the battery. Battery. Our aircraft is equipped with a Hawker Energy sealed aircraft battery. You can see the Hawker Energy sealed aircraft battery. It's a robust, sealed unit designed for aviation use. This battery is a 24-volt 18I unit. It's sealed and maintenance-free, which is a great advantage. It's also fully aerobatic, meaning it can handle extreme maneuvers, and it boasts a long storage life, making it very reliable. Alternator. Next, we have the alternator, which generates electrical power once the engine is running. This image displays an alternator wiring diagram and its technical data, detailing specifications like nominal voltage, maximum current, and output. The alternator is crucial for continuously supplying power to the aircraft systems and recharging the battery during flight. Let's look at its internal components. This diagram shows a breakdown of the alternator's main components. You can see the brush holder assembly, slip ring and head assembly, rectifiers, stator, rotor, and the drive end head. Each of these parts plays a vital role in converting mechanical energy from the engine into electrical energy. Finally, here's where you'd find these components on the aircraft. This figure depicts the location of various electrical power components within the aircraft. You can identify the alternator itself, the alternator filter capacitor, the overvoltage relay, the shunt, the alternator fuse, and the voltage regulator. Understanding the placement of these components helps with maintenance and troubleshooting. Light system 33000. Moving on to the lighting system, which is critical for both interior illumination and exterior signaling, especially during night operations. This image provides a visual representation of the lights system controls and interior lights. It highlights key components, such as the battery, essential bus bars, the central crew light, and various panel lights. Notice the battery is located in the baggage compartment, and the essential bus bar is also clearly marked. An important note regarding the landing light: avoid continuous use of the landing light for more than 10 minutes to prevent overheating. This image illustrates the exterior lights of the aircraft. You can clearly see the green navigation light on the red lights on the wingtips, and the black light, which is likely a white tail light or beacon located on the tail. These exterior lights are essential for visibility to other aircraft and ground personnel. This image focuses on the central crew light system, which is conveniently located on the canopy. It also points out the crew light circuit breaker, allowing for easy control and protection of the system. The central crew light is important for illuminating the cockpit area during night flights. Flight control system 27000. Now, let's discuss the flight control systems, specifically focusing on the flaps, which are electrically actuated. This image presents the indicators and descriptions related to the flaps of the aircraft. It includes a diagram of the flap control selector, showing the various flap settings. The flap system allows us to modify the aircraft's lift and drag for takeoff, landing, and slow flight. This figure illustrates the flap system components and their locations on the aircraft, with photographs and a line drawing for clear reference. Knowing where these components are located is crucial for pilots and maintenance crews. Landing gear system 32000. The landing gear system is vital for safe ground operations, takeoffs, and landings. This image details the controls and indicators within the landing gear system. You can observe various lights, buttons, levers, and gauges that provide feedback on the gear's status and allow for its operation. These controls and indicators give the pilot immediate information about the landing gear position. This figure shows the main and nose landing gear components in detail, highlighting the structural parts that support the aircraft on the ground. This diagram highlights the components involved in the extension and retraction of the landing gear. It particularly focuses on the landing gear emergency mechanism and the control bell crank, which are critical for manual operation in case of an electrical failure. The landing gear position, indicating, and warning components are clearly shown in this image. These include the power lever warning switch, the main landing gear leg uplock switch, the drag brace inboard link, the drag brace outboard link, the main landing gear leg down lock switch, and the nose landing gear down lock switch. These switches and indicators are essential for ensuring the landing gear is in the correct position for flight or landing and for alerting the pilot to any anomalies. Attitude and direction system 34 to 20. Direction, stall warning system, controls and indicators. The attitude and direction system includes safety features like the stall warning system. This figure shows the stall warning system controls and indicators within the cockpit. You can see the stall warning acoustic horn and the transmitter, which are key parts of the safety system. The components for the stall warning system are stall warning transmitter, 3425 S0, one stall warning acoustic horn, 3424 LS01. This system provides a crucial audible warning to the pilot when the aircraft is approaching a stall, allowing for timely corrective action. Let's look at the engine fuel indicating system. The fuel pressure gauge is depicted here, along with its color-coded ranges for fuel pressure, making it easy to interpret the status at a glance. The color-coded ranges for fuel pressure are red indicates 0 to 0.5, and 8 plus psi, signifying a critical condition. Yellow indicates 0.5 to 2 psi, a cautionary range. Green indicates 2 to 8 psi, which is the normal operating range. Here is the cockpit, showcasing various fuel controls and indicators, including the fuel pressure and voltage indicators, providing comprehensive information to the pilot. This figure outlines the fuel tank capacity and usable fuel for the aircraft, essential information for flight planning and endurance calculations. Accurate fuel management is key to safe and efficient operations. Finally, we'll cover the engine ignition and starting system, which brings the engine to life. This figure shows the control panel and cockpit components related to starting and operating the engine. This includes the throttle lever, the mixture lever, and the ignition starter switch, all vital for engine control. This image is a schematic diagram illustrating the connections and components of the aircraft's ignition and starting system, providing a detailed technical overview. This block diagram simplifies the view of the engine ignition and starting system, showing the interaction between the external power source, the battery, the starting motor, and the magneto. This figure presents the location of components involved in the engine's ignition and starting process, accompanied by a photograph of the starter motor itself. Starter motor. The starter motor is essential for initial engine rotation. Its key details are starter motor 8010B01. It features a solenoid-operated pinion terminal for positive electrical connection during starting. Engine ignition and starting. Magnetos. The magnetos are crucial for generating the spark that ignites the fuel-air mixture in the cylinders. The image on the left shows the left magneto, identified as 7410 G01. This image on the right shows the right magneto, identified as 7410 G02. Both magnetos work in tandem to provide reliable ignition for the engine. Thank you and happy flying.